Hello class, welcome back to Algebra 1B Bootcamp. Today we're talking about graphing lines and interpreting those lines. If you're going to graph a line, you have to know the special forms of lines. One way to write an equation of a line, and especially the easiest way to graph it, is to have it be in y equals mx plus b form. Where, if we put some numbers in here, you have your slope, that's your rise over your run, then you have your y-intercept, which in this case would be the point 0,4. From there, you graph. You would plot 4 first, and then you go up 3/1 for your slope. If you know how to graph lines, you can also graph inequalities. Inequalities are the same as lines, except that they have greater than, less than symbols. So you have to know first the greater than and the less than symbol and what that means. So if you're looking at y is less than mx plus b, first you have two things you need to do. First, you need to figure out your slope and your line, your m and your b. Then you have to look at that symbol. That symbol tells you that you shade below the line. And that also tells you that your line is dotted. This one, y is greater than mx plus b. This means you are going to shade above the line. And your line is also dotted. Here, we're similar to the less than, except that we have this equal to. So again, we are shading below because we're less than. Here, your line will be solid because you have an equal to symbol. And again, here we have y is greater than or equal to the mx plus b. So you will shade below the line, or shade above the line, excuse me. And that line will also be solid. Let's do a couple examples. This first example, I have 2x plus 3y equals 12. Well, that does not look like y equals mx plus b. So the first thing I would do would be to make it look like y equals mx plus b. So I want to isolate the y. I will subtract 2 from both sides first. So 3y equals negative 2x plus 12. Then I have to get y totally by itself. So I will divide all numbers by 3. So I have y equals negative 2 over 3x plus 4. And I'm going to graph that line. So I start with my 4. I'm starting at plus 4. I draw my dot. My slope is down 2 and over 3. So I'm going to go down 1, 2, and over 1, 2, 3. Typically, I draw enough dots to fill my whole coordinate plane. I could also go up 2 and backwards 3. Since I don't have any greater than or less than symbols, I don't have to worry about shading or dotting. I just draw my line. Now let's look at this one. It's an inequality. First, y is not by itself. The first thing I need to do is divide everything by 3. So y is greater than 2x minus 12 divided by 3, that's 4. So first I start like a normal line. I go to negative 4. And then I do my slope. My slope is 2 over 1. So I go up 2 over 1, up 2 over 1. And again, I draw enough dots to fill my whole coordinate plane. Now I have to decide. Looking here, y is greater than, so that means I'm above my line. So you have to shade above your line. You also have to decide whether this line is dotted or solid. Since it's not equal to, it's dotted. And so you connect your lines with a dotted line. You connect your dots with a dotted line. Our next graph is known as a system of inequalities, meaning that we have two different inequalities that we're going to graph in the same coordinate plane. Our answer is where the two shaded regions overlap each other. So first, looking at these, they're both in proper y equals mx plus b form. So my first line, y, is less than negative 3x plus 1. So I'm going to start at plus 1. My slope is negative 3 over 1, so I'm going to go down 3 and over 1. And I definitely need to make sure that I fill my whole coordinate plane this time. I'm going to run out of space if I go anymore. I got to decide dotted or solid. I know I'm dotted. And since it's less than, I know I'm below. So you might want to be careful in how much you shade and how aggressively you shade, because it might be hard to tell where your graph is and what's happening in your graph if you make it too dark. Now let's do the other graph. It might be beneficial to you to use different colors. So I'll switch to red here. Y is greater than or equal to x minus 4. So I know that I'm a solid line. I also know that I am greater than, so I'm going to go above. So I start at negative 4. 1, 2, 3, 4. My slope is not x, my slope is 1. So that means I just go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I go down 1, backwards 1, like this. I'm a solid line, so connect my dots in a solid fashion. And I'm going above the line. Now, my answer is technically where the two graphs overlap. So you might want to take a third color or just make it really dark. But this is my answer, technically, the part that I have made black. Now let's talk about an application of lines, which would be the line of best fit. The line of best fit typically deals with a scatter plot. It's a bunch of dots that represent some kind of data. Now, several things that you need to be able to do about line of best fit is determine the correlation. Typically, you can have a positive correlation, a negative correlation, or no correlation at all. This graph has a negative because if you read it from left to right, the dots appear to be going down. In general, they're going down. They don't all follow the exact same perfect pattern like the graphs that we made from our equations, because this is coming from real life data. Our dots are making a negative kind of slope. If we had more dots that were kind of all over the place, that would be no correlation at all. And you can't really make conclusions from that. Now, here's a phrase you might not have heard, and this is called the correlation coefficient, also referred to as the R value. You want to definitely make sure you write down this definition. Correlation coefficient is just how close the graph is to being linear. If your graph has a correlation coefficient that's close to 1 or negative 1, that means you are close to being a line. If your graph is close to 0, either coming from the positive or negative direction. If it's close to 0, then you're not linear. You could have a different relationship, but it's definitely not going to be linear. So whenever you see it talking about the correlation coefficient, you could describe it as a strong coefficient or a strong relationship, meaning that it's almost a line. And I would call this relationship fairly strong. Or you could call it a weak relationship, meaning that it's not really close to 1 at all. Or it could give you actual numbers like 0.73 or 0.5. And you would have to determine whether or not that is a strong correlation or a weak correlation. Again, closer to 0 would mean weaker. And finally, we are interpreting and making predictions with our graph. So for example, in this graph, I could ask you to read off any data points, like, what's the y-intercept? Well, the y-intercept of this graph is right there, which I would estimate would be 35. I could ask you, what does that y-intercept mean? And you would have to look at your scale, your label over here, average emails per day. So the y-intercept, if a person is 0 years old, they would get 35 emails a day, which doesn't really make sense. So this y-intercept doesn't mean anything because a 0-year-old is really not going to get emails. But it could ask you to make a prediction, like, why do you think this graph is correlating negatively? Why do you think the line is going down? And you could say something as simple as, well, the older somebody is, the less emails they get in a day, or something like that. So be prepared for that when you get your assignment.